All right, hey class, this is Gigi, question 2B and written assignment number 5. So the question is asking us to go ahead and find the interval of which this function is increasing and when it is decreasing. So the function is increasing or decreasing when the derivative is positive or negative, right? So the first thing we're going to have to do is we are going to have to find the derivative of this function. Okay, so the derivative is 2 cosine of x multiplied by the inside derivative, which is negative sine of x, minus the derivative of sine is cosine of x. I said cosine of x twice, so I know that I could go ahead and factor out cosine of x. As a matter of fact, there are two negatives there. So I'm going to go ahead and factor out negative cosine of x, and that should leave me with 2 sine of x minus, actually, plus 1. Okay, so that is the derivative, and the critical points are when the function is undefined or when the function is 0. Now we know that sine, cosine are always defined, so and especially on the interval from 0 to 2 pi, so the function is, the derivative is always defined. So we only need to look at when the derivative is 0. So the derivative here is going to be 0 when cosine of x is 0 or when 2 sine of x plus 1 is 0, right? So either cosine of x is equal to 0 or 2 sine of x plus 1 is equal to 0. So that means when is, let's just look at the unit circle, okay? And we're looking at the unit circle and we are asking when is cosine 0? Cosine 0 is right here or right there, okay? Oh, wait a minute, that's not cosine, that is sine. Cosine is 0, here's the correct one, up here or here. So that would be pi over 2 or 3 pi over 2. And we call that pi over 2 and 3 pi over 2 is because we are on the interval from 0 to 2 pi. Okay, so we will have x is equal to pi over 2 or x is equal to 3 pi over 2. Okay, so next on this side, we would say sine of x is equal to negative 1/2. And the question now is, when is sine negative 1/2? Well, sine is the y value, right? So negative 1/2. When is sine negative 1/2? Let's go and take a look here. Negative 1/2 is right here. So either we have this angle right here or this angle right here. And we are going from 0 to 2 pi. We're going from 0 to 2 pi. So we're looking at this angle being 7 pi over 6, or this angle being 11 pi over 6. So we would say here, if not sine, but x is equal to 7 pi over 6 or 11 pi over 6. So those are the points that are in the interval 0 to 2 pi that are your critical points. Okay, so these are your critical points. So these are your critical points. And what are we doing with the critical points in order to find out when the function is increasing and decreasing? We have to go in between, right? We have to go and check what the behavior is of the derivative in between 0 and 2 pi, and the cutoff points are, let's put these in order. Okay, so going from 0 to 2 pi, the first thing I'll hit is pi over 2, and then 7 pi over 6, and then 3 pi over 2, and then 11 pi over 6. So these are your critical points when the derivative is 0. Now what are we going to do next? We're going to check in between, right? What are we checking? Whether the derivative is positive or negative. Positive is increasing and negative is decreasing. So let's just go ahead and give it some room right here. And we're checking for the derivative. So we need to look at the derivative being, here we go. I'm going to rewrite that. The derivative is, and we want to know if it's negative or positive. So negative cosine of x multiplied by 2 sine of x plus 1. Okay, and we only need to check to see if the derivative is positive or negative. So let's pick a number in between 0 and pi over 2. Well, a good one is pi over 4. So let's go ahead and check the derivative of pi over 4. And we want to know if the derivative is positive or negative, so you don't really have to do the computation. Just think about that. If x is right there, then the cosine value is positive. There's a negative in the front, so this part is negative, multiplied by sine is square root of 2 over 2 times 2, which be square root of 2 plus 1, that is going to be positive. Negative times a positive is going to be a negative. So right here we have a negative value. The function is decreasing. And then we would check next at, say, after pi over 2, in between pi over 2 and 7 pi over 6, let's just pick pi because that's a nice angle there. So cosine of pi is -1. -1 with a negative in the front, so that's going to make that positive. And then sine is 0. 0 plus 1 is 1. That is positive. So we have a positive value here for x being pi. Therefore, this interval right here is increasing. Okay, and then next we will look at the value from after 7 pi over 6 to 3 pi over 2. Well, how about this guy right here being, say, 7 pi over 4. 7 pi over 4. The cosine value is negative with the negative in the front, so that's going to make it a positive. Sine of 7 pi over 4 would be a negative, and that would be a negative square root of 2 over 2 times 2. That would be negative square root of 2, which is square root of 2 is greater than 1. So negative square root of 2 plus 1 is going to be a negative number. Therefore, the result is going to be negative. So this right here is negative. And so this function is decreasing in that interval. Okay, next we are going to check on a number between pi over 2 and 11 pi over 6. So we're going to check right here, and that would be 7 pi over, oh no, that's not 7 because oh, what did I call this one? This one right there was not 7 pi over 6. I meant to say 5 pi over 6. Let's see. Okay, that was 5 pi over 6. And then the next one right there is 7 pi over 6. Okay, so 7 pi over 6 is right there. So we would say the derivative of 7, not 7 pi over 6, 7 pi over 4 is cosine is positive with a negative in the front, so that would be negative. Sine would be negative square root of 2 over 2 plus 1 is going to be negative. Negative times a negative number is a positive number. So this is positive, so your function is increasing here. Okay, then next we would go ahead and pick a number in between 11 pi over 6 and 2 pi. Okay, so what value is in between 11 pi over 6 and 2 pi? Oh, say a really small angle right there. Say a tenth of a pi short of 2 pi. So 2 pi is 20 over 10. So that would be 19 pi over 10. Okay, so that's a really tiny angle right there. Cosine is positive because it's in the fourth quadrant. There's a negative in the front, so that's a negative. And then sine is a negative number that is less than 1/2. A number that is less than 1/2 multiplied by 2 is going to be less than 1, plus 1 is a positive number. So this is going to be a negative number. This is negative, therefore the function is decreasing in that interval. Okay, so to answer this question, we would say our function is increasing on the interval of pi over 2 to 7 pi over 6 union 3 pi over 2 to 11 pi over 6. Those are the two intervals that the function is increasing, and the interval is decreasing in the interval from 0 to pi over 2 union 7 pi over 6 to 3 pi over 2 union 11 pi over 6 to 2 pi. That is our final answer. Okay, but the process is, in order to find the interval of increasing or decreasing, we need to take the derivative, find the critical points. Critical points are when the derivative is undefined or when it is 0. So in this problem, the function is always defined. The derivative is always defined. So we're only looking at when the derivative is 0, which gives us those in highlighted part there. Those are our critical points, and we check in between to see if the derivative is negative or positive. You don't necessarily have to do the math. All you got to do is just, estimate and make sure that we know whether it's negative or positive. Okay, that is it.